Holy shit, that's awesome.
The way that it works is that we have this center aluminum piece, which is press fit onto the motor, so it spins along with the motor. So this shaft is free to independently rotate around the bearing, which is in red. The bottom side system with the two smaller idler sprockets and the main sprocket on the bottom, which is securely fixed, is what determines the overall velocity of the shaft. So this entire bottom system down here is what determines how fast the shaft spins at the top. The output, if there is no chain, is free to spin independently of how the motor spins, because we have this bearing down here, and its spinning is determined by the speed of these two sprockets up here. So that is how the orbital drive mechanism works. It'll make a bit more sense after we go ahead and build the thing, and you can see for yourself. The reduction is determined by this equation here, which is the same as the cycloidals. The original builder of the orbital drive used belts, but I think I'm going to use chain. Hopefully this doesn't prove to be problematic. I began by making the steel sprockets. I did this on a metal laser cutter since it was the easiest way for me to make sprockets. After cutting the sprockets, I went ahead and ground down the teeth so that they would be sharp and fit inside the chain. After making the sprockets, I went ahead and started to CNC mill the center aluminum piece, which would need to be press fit onto the motor. It's imperative to get a good press fit here.
Bro, is this supposed to be a press fit? I put in 0.5 rather than 0.05 of stock to take off.
Yeah, so this is a really bad press fit, but as an engineer, I have plenty of jank solutions to fix this problem, so I went ahead and cut the part out and we'll fix it later on. Now I'm using a normal laser cutter to cut these little wooden guides that will help me align the sprocket while I figure out how long the chain needs to be. This is mostly a time-saving thing because although I could put it together and figure out the chain then, it gave me something to do while the CNC machine was running. This is a chain breaker tool. If you ever wondered how you can disassemble chain, you could just do this. It pushes the pin out. And here I'm using something called a master link to put the chain back together. Alright, here's the jank solution I was talking about. I just wrapped the motor in tape to give it a little bit of extra thickness. And let's see if jamming a bunch of tape on the outside actually worked.
So many times we're texting each other out.
Yup, it's on there pretty well. Now we can go ahead and assemble the rest of the system. Most of the other parts are 3D printed. I went ahead and decided to make the shafts 3D printed, even though I should have done it on aluminum, because I was like, oh, it's just a prototype. It never made it out of the prototype phase.
Spin this ever so slowly. You can see the top little gear rotates a bit.
Here's the issue with chain. It's kind of hard to get the tension perfect. So I went ahead and made a half link because I didn't have one on hand, and if it worked I would have bought one. So just a little tiny screw and some bent chain, and then I'm using a master link to put it all together. And after putting it all together, it didn't help at all. So my solution is just hold it horizontally instead of vertically. And it worked. The person who originally built the orbital drive never actually tested the thing, and I thought that was kind of a shame. So I thought I might as well go test it, so people in the future might maybe have a baseline on what to expect when using this gearbox. It's also not backdrivable. I think that's a chain tension issue again. Now I get why the original poster used belts. The orbital drive is really mesmerizing though. Here's the setup. I put a polycarbonate sheet in between me and the motor because I feel like it might kill me. That clicking sound you're hearing is the chain skipping around the 2 Newton meter mark. Yeah, so the motor starts skipping at about 350 ounce-inches, something about 2 Newton meters. Again, chain tension issue. Yeah, belt is starting to make a lot more sense. Here is me testing at a different angle though, and you can see how the plastic shaft interacts with the dynamometer. Alright, the final test I decided to do was test it at max speed and max power. And this one, I really feel like it might explode. So I put it in a test cage meant for combat robots. Just in case if it blows up and sends the chain flying, I don't get hurt. I'm not sure why, but it starts bouncing here. It's like it's trying to get away from the camera. I'll leave you guys with some slow-mo footage. If you like the content that you're seeing, feel free to subscribe.